Okay, so we are going to go over a few questions for the review for Chapter 2. There are a few problems on the review that everyone asks me about every year, so I thought I'd just make a video for everyone at home who would like some help on the review. All right, so the first thing I want to go over, we spent a lot of time doing this in class, so it's definitely going to be on the test. We're going to find the 5-number summary, the mean, and the standard deviation of this data set. Okay, so here we go. Let's go ahead and find the 5-number summary. Okay, the 5-number summary is going to be my min. Got to figure out what that is. I got to figure out my Q1. I got to figure out my Q2, my Q3, and no, I already did 3. Hold on a second. Let me erase that. I got a little carried away with my Q's. What's the last one? The last one's not Q. The last one is going to be the max. Okay, so the first thing I need to do in order to find the 5-number summary is I have to put the numbers in order. So the first number is 0, and then I have 2 ones, so then I'll have 1, 1, so cross those off here for a minute, and then I have 3 2's, 1, 2, 3. I'm going to cross those off so I don't miss any. All right, and then let's see, I have a 3, I have a 4, and I have 2 6's. Now, based on these numbers, I doubt that any of these numbers are outliers. So I'm pretty sure that 0 and 6 are my min and my max, but I'm not going to write those down yet because before I can say that those are my minimums, I have to check and make sure that there's no outliers. All right, so first thing we're going to do is we are going to, oh, there we go. I'm going to cross one off at the beginning and at the end, beginning, end, beginning, end, and I'm going to keep going until I get to the middle. Now I've got 2 numbers that are in the middle. So in order to find the second quartile, I'm going to add them up and divide by 2. So if I do 2 plus 2 is 4, divide by 2, quartile 2 is going to give me 2. So I'm going to draw a line here, and that's my quartile 2. And that was 2. All right, now I want to go ahead and find my, oh, I don't want to use green. I already have green. I was writing in green. Let's do orange. All right, so now I'm going to cross off from the beginning. And then this 2 is not actually the quartile 2 because it was in the middle. So I'm going to cross here to find the first quartile. Cross, cross. That gives me my quartile 1 at 1. So I'm going to write that down over here. And then we're going to cross off, cross off, cross off, cross off. And that gives me my quartile 3 at 4 over here. I guess I probably shouldn't try to write with a highlighter. It makes it look a little big. All right, so now I need to check to see if I have any outliers. So first thing I need to do is find the IQR. So the IQR is the quartile 3 minus the quartile 1, which is 3. So my IQR is 3. So I take my quartile 1 and I subtract 1.5 times my IQR, which is 3. And let's see. Okay, so I've got 1.5. No, sorry, that's not right. I've got 1 minus 1.5 times 3, and that's going to give me negative 3.5. Do I have any numbers over here that are smaller than negative 3.5? No, 0 is bigger, so that means 0 is my minimum. No outliers on the left side. Now I got to check on the right side. So I'm going to do 1 plus 1.5 times 3. And there's a mistake. You guys are probably at home going, wait, quartile 3 is not 1. Quartile 3 is 4. Thank you for telling me. I so appreciate you guys reaching out to me. Okay, so 4 plus 1.5 times 3 is going to give me 8.5. Okay, so if I do 8.5, all right, are any of the numbers bigger than 8.5? Nope. None of the bigger numbers are bigger than 8.5, so my maximum is going to be 6 because there's no 6 is not bigger than 8.5, so it's not an outlier. So this data set has no outliers, and this is my 5-number summary. Okay, now we're going to go ahead and find the mean. The mean, the data doesn't have to be in order. So I'm just going to erase all this so I have a little bit more room to work. Okay. The mean is when we add all the numbers together and divide by the number of numbers. So I'm going to take all of my data points and I'm going to add them together. And when I add all these together, I get 27. And I'm going to divide by the number of numbers. And let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's where I got the 10 from. There's 10 numbers, so 27 divided by 10. My x with a bar on top is going to be 2.7. Okay, so now I need to find the standard deviation. So I've got the 5-number summary, I've got the average. The standard deviation, the formula says S is equal to the square root of the sum of x minus x bar squared divided by n minus 1. Okay, so here we go. Let's go ahead and start working the numbers here. I'm going to write down my x value. I'm going to write down my x minus my x bar. And then I'm going to take that answer, x minus the x bar, and I'm going to square it. So my first number is 2. So we're going to do x, which is 2. Minus my x bar, which is 2.7. And let's see, what do we have there? Oh, I don't know why I just drew a line there. There should be no line there. So 2 minus 2.7 is going to give me negative 0.7, and I'm going to take that and I'm going to square it. So negative 0.7 squared is going to give me 0.49. Okay, and I've got 1, 2, 3 2's. So I'm going to do that once, twice, 3 times. And so I'm not going to write this over and over again, but that's 0.49 over here, and that'll be 0.49. Okay, so I've got the 3 2's done and taken care of. All right, now I've got 0. Okay, so let me do 0 next. If I put 0 here, 0 minus 2.7 is 2.7, negative 2.7, and negative 2.7 squared is 7.29. All right, let me see what's the next data point. The next data point is 1. So if we do 1 minus 2.7, that's going to give me negative 1.7, and negative 1.7 squared is 2.89. So let's see, there's a 1 and there's another 1 over here. So I have another 1, and that'll be another 2.89. Okay, so my next number is 6. So we're going to do 6 minus 2.7, and 6 minus 2.7 is 3.3, and 3.3 squared is 10.89. And I've got 2 of those, so I'm going to write it again. So 6, and this will be 10.89 again. All right, so I got that other 6, and now I have a 3 and a 4. So I have a 3 and a 4 left. Okay, so 3 minus 2.7. So 3 minus 2.7 is going to give me 0.3. and 0.3 squared is 0.09. And 4 minus 2.7 is 1.3, and 1.3 squared is 1.69. So the part in here that I'm working on is this part right here, the sum of x minus x bar squared. So what that means is I'm going to take all of my x minus x bar squareds, all of these numbers, and I'm going to add them up. So I'm going to take out my calculator, and I'm going to type in 0.49 plus 0.49 plus 0.49 plus 7.29 plus 2.89 plus 2.89 plus 10.89 plus 10.89 plus 0.09 plus 1.69. And I get, let me get my pen back out here. I get that adds together to be 38.1. So my standard deviation, instead of putting all of this, I'm going to put 38.1. Divide by, okay, now n minus 1. N was the number of numbers we had. So I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So 10 minus 1 is 9. Okay, so then 38.1 divide by 9, and then take that answer and square root it, is going to give me 2.058. All right, so my average was 2.7. My standard deviation was 2.05. My 5-number summary was 0, 1, 2, 4, and 6. Okay, so we're looking pretty good here. Okay, so now just to make sure that you understand what this means, on your 5-number summary, we're going to put a point at 0. We're going to put a line at 1. We're going to put a line at 2. And then we have 3, and then we have 4. We'll put a line at 4, 5, and then at 6, we're going to put a point. And then we draw our box and whiskers tells us the variation around center. So it tells us what the spread is from the center. Okay. Well, in the mean was 2.7. And then if I go backwards 2.05, that's going to give me 2.7 minus 2.05 is 0.65. And if I add 2.7 plus 2.05 is 4.75. Okay, so if I look at these data points, 0 is outside of that and 6 is outside of that, but all of the other data points are within that range. So it gives me my variation. It tells me how far away from middle my points are. So they're both telling us the same thing. It's just a different way to look at it. Since this data is not skewed, the mean and the median are roughly in the middle. They're roughly about 2-ish. And my standard deviation and my 5-number summary are telling us how far from that middle we are. Okay, now I'm going to escape out of the, oops, hold on a second. I want to, hold on a minute. I want to end the show for just a second. Nope, I want to discard all these things. And I want to show you on the calculator. Okay. So the same problem that we just did, I want to show you that you can do it on the calculator as well. So let me zoom in a little bit so you can see this screen just a little bit better. Okay. Okay, there we go. Okay, so if you go to stat on your calculator, it's right there below delete. If you press stat and then press enter on edit, I go up to L1 and press clear and press enter. It'll delete everything that's in that column. And now I'm going to type in the data points. So 2, 0, 1, 6, 4, 6, 2, 2, 1, And I sometimes hit the wrong key, so I'm just going to make sure that I typed it in correctly. 201 6. See, I missed one. I missed the 3. And then 6 2 2 1. Okay, I missed the 3. I got to put that in there. I'm glad I double checked myself. Okay, now I'm going to press stat, and I'm going to move the cat over to calculate, and I'm going to press enter on one variable stats and press enter. It gave me that my average was 2.7. S sub x is my standard deviation. If I go down, it tells me that my minimum value right here is 0. My quartile 1 is 1. My median, my quartile 2 was 2. My quartile 3 was 5. And my max is 6. So it gives me my 5-number summary, the mean, and the standard deviation in the one variable stats. Okay, so that's that. Let me minimize this. And let me go back into here. Okay, so are there any outliers in the following data? So in order to see if we have any outliers, let me start the presentation again. I need to figure out what the quartiles are. So I'm going to put the data in order. The smallest is -6, and then I go to -1, and then I have a 0, and then I have 2 2s, 1, 2, so 2, 2, and then let's see, I see a 3, a 4, a 3, a 4, a 6, a 7, and a 12. Okay, I got it all. And now we're going to go find our quartiles. So our quartiles, oops, cross off the beginning, cross off the end. Beginning, end, beginning, end, beginning, end. So we're here. So the middle of that is going to be 2.5. So I'm going to write that down. Where did my pen just go? I lost it. Okay, there we go. 2.5 is my quartile 2. All right, and now we're going to look at quartile 1. So we cross, 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 cross. We're looking at 0. So 0 is my quartile 1. And then we cross, 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 cross. And we're looking at 6 as my quartile 3. All right, so now let's go ahead and figure out what the IQR is. The IQR is my Q3 minus my Q1, which in this case is 6. And now I start with my Q1 and I subtract 1.5 times my IQR, which is 6. So I'm going to grab the computer and I'm going to do negative 1.5 times 6, and that gives me -9. Now, -6 is my smallest data value. Is -6 an outlier? No, it's not, because it's not smaller than -9. Okay, so now we're going to start with our Q3, and we're going to add 1.5 times 6. So I do 6 plus 1.5 times 6 is 15. So is 12 an outlier? It's not. Man, I actually thought 12 was going to be an outlier. Was mistaken. What if I change this now? So let's not make this 12. Let's make this 22. Okay. If I made this number right here 22, would any of the other numbers change? No. Everything else, all of the other math would be the same. So I'm going to make this a 22. All of the other math is going to stay the same. But now, if my Q3 plus 1.5 times the IQR is 15, 22 is bigger than 15, so that 22 would be an outlier. Okay, given that 126 students took the exam and a 5-number summary was given. Okay, so this 5-number summary is the 4 parts on the graph. So this is my point. This is the quartile 1, my quartile 2, my quartile 3, and my max. Okay, so this is my box and whiskers. Okay, how many students scored between 73 and 82? Well, 73 is right here. and 82 is right here. So let's think about what percentage of the data that is. So if I look, this is split into 1, 2, 3, 4 sections of graph. If I take a dollar bill and split it into 4 pieces, wouldn't I get a quarter for each piece? So this is 25%. This is 25%. This would be 25%. And this would be 25%. Okay, so between 73 and 82, that is right here. There's 25% of the data between 73 and 82. So 25 out of 100 is equal to what, right? How many students, number of students out of the whole 126? So if I cross multiply 25 times 126 and divide that by 100, that's going to give me 31.5 students. Now, if they don't have the 0.5, you're going to pick either the 31 or the 32. That would technically round to 32. But if they don't have that as an answer choice, pick the 31. Okay, next question. How many students scored above a 91? Well, a 91 is from right here and above. Well, that's 25% of the graph. So I don't need to do any work. I already know that. 25% over 100 is the same answer, 31.5 students. Okay, so what percentage of the students scored greater than a 73? Well, that would be 75%, right? What if this was above a 73? Okay, so that would be 1 section, 2 sections, 3 sections. So that would be 75 out of 100 is equal to X out of 126. So 75 times 126 divide by 100 is 94.5 students. Okay, same 5-number summary, same number of students. What is the shape of the data? Okay, so I start at 61 and I go to 100, and then I've got most places like, is this 61 or is this 100 way different from the rest of the data? No, they're pretty close to the same thing. So I would say the shape of this data is symmetric. Okay, well, if the data is symmetric, what do we know about the mean? It's approximately the same as 82. So we would say the same as the median. Okay, so let's look at the next one. All right, so in this one, we still have 126 students, and here's my 5-number summary. What's the shape of the data? Okay, do you see how this 11 changed? The distance between 11 and 73 and the distance between 9 and 100, or 91 and 100, I only have 9 right here. Here, this is going to be 62. So which side is going to have a bigger tail? The left side is going to have a bigger tail. This 62 is a lot bigger than this 9. So let me write that down. That's a difference of 62, and that's a difference of 9. So if I go back, and let's make sure this makes sense to y'all. Right here, I have a difference of, let's see, that's 12. And over here, I have a difference of 9. I mean, they're not exactly the same, but they're pretty close. I wouldn't say that one is extremely bigger than the other. Whereas over here, 9 and 62, that's a big difference. So that difference happens on the left-hand side. So I would say that this data is skewed to the left. The tail is going to be on the left side. What do we know about the mean? If we know that we have data that's skewed to the left, the mean is going to pull left. So this is going to be smaller than my median. And my median in this case is 82. It's going to be pretty significantly smaller than 82 because that outlier pulls the data, pulls the mean so far to the left, so far smaller. Okay, next problem. Dr. Stat's library of literary classics includes issues of many scholarly periodicals. the total number of issues of these 5 periodicals together with their percentages of Dr. Stat's entire library that they combine are given in the table below. Note, this is not his entire collection. Okay, so are all of these percentages correct? So let's look and see what we've got. We are saying that Spider-Man's percentage of the collection is 21%, which would be 21 out of 100. So the Spider-Man comics that he has is 168, and we don't know what the whole is. Okay, could I just add these up? No, because it says this isn't his entire collection. So if I cross multiply that, 100 times 168 divided by 21 is 800. So right here, if this percentage is correct, the whole is going to be 800 comics. So let's see what we've got over here. 8% would be 8 over 100 is equal to 64 out of my whole. If I cross multiply that, 64 times 100 divided by 8, x is 800. Okay, if I do the same thing over here, 7 over 100 equals 56 over x. If I cross multiply, that's going to give me 800. Okay, let's keep going. Here, this would be 10 over 100 is equal to 76 over x. If I cross multiply, that's going to give me x is equal to 760. And over here, this is 4% out of the 100 is equal to 32 out of x. If I cross multiply, that gives me x is equal to 800. Okay, so are one of these not like the rest? Yeah. This guy right here, this Mad Comics, doesn't have the same whole as the rest of them. So I would say this 10% is probably not correct. Okay, in an article about the airport flight delays said, Chicago O'Hare's flight scheduled 114,370 flights, nearly 10%. 1,136 were canceled. The correct percentage canceled was, okay, so it says that it's 10%. Okay, so let's think about what we know. We know that percentage is part over whole. Okay, so if percent is part over whole, the part of the flights that were canceled were 1136 divided by the whole of the flights scheduled was 114,000. Oh, you can't see that. Sorry. 114,370. So if I divide 1136 by 114370, I get 0.0099. Okay, so if I move that decimal place over 2 places, that's going to give me 0.99%. Is that 10%? No, that looks like it's a typo. It shouldn't say nearly 10%. That's wrong. What's the correct percent? It should be about 1%. Okay? All right, so the median goes with the 5-number summary. The mean goes with the standard deviation. The mean and the median both measure center, and the standard deviation and the 5-number summary measure the variation, the spread of the data. And that's the end of the review. I hope you guys have a good day. Please, please, please let me know if you have any questions. I like to answer questions. So please